Okay, introduction, Synerflight on drones. Everyone's getting me on this now, huh? Clear? Okay. So to get started, we want to discuss pretty much the basics on when you're building a UAV. Now, the anatomy of a drone here in this description shows a very basic format of your typical multi-rotor quadcopter. Have the here. Wrong window. Wait. Okay, I'll flip it over to the other side. Wait, stop. Wait, I'll switch it over again. Show. Okay. Clear now? Good. Presenting. Is anyone seeing a presenting screen, the whole thing?
Yes, sir. It's already presented.
Okay. So that's it. I just do it basic. Let's do a run through with this. Okay, introduction for the Synerflight. Introduction to drone basics. You're getting me now, huh? Okay, so dynamic remote operated navigation equipment. Probably this is one of the acronym the guys have came up with. On the basic, basically any aircraft or unmanned vehicle, doesn't have to be an aircraft, can be a ground vehicle, can be a watercraft. Now, the reason why it became synonymous is because of the aircraft that it has been developing around recently. So going through, we have the anatomy of your basic DIY drone. If any one of you already have done this project, I'm sure you're pretty much familiar already with at least the basics of it. You have your structure, which is your airframe. You have your propulsion, which encompasses your motors, propellers, and mechanics, as well as your power supply, which is your battery. Are you guys still getting?
Yes, po. Yes.
So the flight controller encompasses the electronics, sensors, communication, and your flight controller. That also includes your ground station. Payload, that will be part of the drone, but it's externally, meaning the drone can operate with or without the payload. So meaning if your drone has camera, you consider the camera as a payload because it's not part of what makes a drone operate. It's just essential because you place it there. Let's say the reason why it has camera, it's because you're using it for mapping or photography reasons. So that is a payload. Okay, so what's a multi-rotor? The reason why it's called multi-rotor is it has 4 motors, 4 rotors, providing lift and stability. The reason why these things are very possible nowadays is like our last presenter discussed about the IMU, the gyro accelerometer that makes them fly. Now, of course, not always the quadcopter. There are so many configurations you can play around with. It's just the quad is the most simplest and the most basic you can actually work with. So let's go back to the basics. So you have 4 motors. Now, if you're hovering, your motors run in equilibrium, meaning all the motors are running at the same speed. But let's say you hit your pitch control, you want to move forward. Your rear motors will go faster, your front motors will go slower. Same too with roll control. For yaw, because the multi-rotor uses counter-rotating in a diagonal fashion, it relies on torque to actually rotate. Okay. Still getting me?
Yes, po. Yes, sir.
I think I have a preview there. Okay. So let's continue on. Now the motors. The motors is a brushless DC three-phase motor. The reason for three wires coming out, which I can show it here. I'll show it to you guys later. Electronic speed controllers. So primarily the drone uses a brushless. You have a three-phase motor, so you need a three-phase speed controller to operate them. And this is one of the conceptions people are asked. Can I use a cell phone to fly it? Now, technically, yes, you can do it. But preferably, the reason why for a proper transmitter is you need tactile feedback control, which a touchscreen doesn't offer. So this is your basic radio. You have since this is a mode 2, which your elevator and ailerons on the right, your rudder throttle controls on your left side. Your receiver. Now there are two types. You can actually use the classic PWM, where each channel representing each control. Let's say in this case, you can have channel 1 as your throttle, channel 2 as your roll or aileron, channel 3 as your elevator, channel 4 as your rudder, and so forth. Now, different brands have different configuration. The brand I was showing was a JR type, but this one is a FS, so it's a Futaba configuration where the channel 1 is your ailerons, channel 2 is your elevator, channel 3 is your rudder, throttle, channel 3 is your throttle, and channel 4 is your rudder. Now, the PPM is basically a compilation of that by signal you get through. And of course, the battery. That's your power source. Other accessories would involve your Bluetooth and GPS. This actually is one of the important things. Bluetooth, because you need to have telemetry data from your drone. GPS is, of course, you're familiar. Your drone navigates using GPS. Okay, go. You guys are still getting me?
Yes, sir. Yes.
Okay. So one of the recent requests on the Arduino robotics, this one actually came in as early as 2017 when they suggested, why won't we just do a Arduino-based drone, which for the most part, a lot of people here familiar with Arduino-based robots. So the question is, why not the drone? Why can't we have a Arduino-based drone? So back in before 2007, at 17, I was experimenting with a Mega 2560 Mega IMU sensor. This was featured in Matanglawin as well as in, well, Maker Faire. It was present during the first Maker Faire, and this one actually grabbed the attention. So you can see that it's not only drones, but the shield encompasses other vehicle type. It just so happened that the aircraft seems to really grab the attention of the market. So here we are in 2021. We introduced the launch of our Synerduino shield. Now to make it for students to build, it accepts both Uno and Nano. So you can, Uno and Mega, you can use any of the boards. Yeah, one of the main features, of course, this is the outline of what you will be required. Prerequisites would work on if you have experience in soldering components in your breadboard. That would be a plus. This is the quad shield. We'll get on. It's one of the early test flights. Okay. This is a demonstration with old. Skip that one. Now, to be surprised to you, we use a mega board on this one. However, you can use a Uno board. It's just the mega board has more serial pins and functions, so you can actually utilize the GPS. This wasn't possible on a Uno board. So it's a relatively stable once it's tuned properly. It's relatively stable aircraft. Okay, this is another shot we did right before lockdown. In fact, it's very windy that time. So it's not your typical toy drone. It can fly outdoors. It can sustain up to a degree of some winds. We'll skip it to the part where it's... okay. Now, if you can see here, I was demonstrating the Loiter Mode. Essentially, the drone is flying itself. I was just holding the remote, but not touching the controls. It's completely autonomous. One of the fun fact is you can actually set it up on follow mode when you have a ground station with a GPS, let's say your phone. It's very useful toy, but it's also practical. Okay. Okay, so here it is. Now it's an Arduino-based programming. Means it has a raw codes. It doesn't use libraries or plugins. It's straight from the sketch. Now on our website, you can actually download these things. We also have it preset, so it allows you to get started quickly. The introduction of the basic Arduino, meaning you work with motor drivers, serial communication, GPS, and I2C sensors. Now the beauty of it is it's unlike libraries. You can clearly see exactly the raw codes which extracts, especially the registry. It extracts the registry. Now these are the functions your drone has available on Uno and Mega plus the GPS. Okay, so prerequisite, basic soldering, robotics skill, and at least reading circuitries and connection layouts. So if you have done previous robotic projects, this is be a good expansion. Now, I'm not saying I'm limited to quadcopters, but you can build almost any configuration you want to do here. You can do custom mixing if you have an aircraft or vehicle that has a awkward configuration. You can actually work on it. And we have included the Gui GUI User Interface. This is the telemetry function. You communicate to a ground station. Okay, we have, oops, sorry. Okay, we have mission planning and logging. One of the interesting functions is this is the reason why you can actually do missions. You set waypoints. It's basically like a professional drone in a sense that you have all the mission capability function, but it's on an Arduino, so you can custom build your drone in whatever projects or configuration require them to do. Now this is the drone. Wait, we use this on a different drone, a flame wheel. This was taken like 3 years ago. Okay, so you can see here, this is the waypoint autonomous flight. And a little known fact is our analog sensor, we can discuss later on analog sensors, but this is one of the application. We stuck a gas sensor into the module and then able to log data of who farted. Okay. We'll go for the rest of it later. So you can actually, if you have any questions or something about drones, we have a page here called Drones Developer Philippines in Facebook. It's a community for people who actually does, designing flight systems or airframes. Hold on. Can I switch to camera mode first? Hold on. Is my screen still presenting?
Yes, sir.
Okay. Now, let's move on to the other one. So basically, this is the sketch, Arduino. Are you guys seeing it?
Yes, sir. But it's a little small.
Little small.
A bit.
Never mind. I have another option. Okay, about this. Okay, so essentially, these are the softwares you download. Now, the Flywheel UI was from the Synerflight website. We just redeveloped the software to accommodate our new drone with the new configuration. The Arduino IDE, there's nothing else. You just get the Arduino IDE. You can download from the Arduino website. The U block is when you want to set up your GPS. And the XCTU serves as your telemetry for people who wants to, the XB. Hold on. Let's get started. Okay. Can I switch to video device first? Okay. Change to video device. Change for that. Okay. Wait. Hold on. How do I switch it to my camera mode?
We're already seeing you, sir.
Okay, so this one is the XB. There are many ways of communicating. You can use the SIK radio. This is 433 megahertz. You can use the Zigbee, which is 2.4, or you can use the Bluetooth. So there are many ways of communicating with your drone. This is the shield that we presented. So it's a Synerduino shield. It's the Mega. It's accomplished by plugging it in. Okay, let's go back to your screen. Okay, so we go back to the entire screen again. Skip it. So this is how our board looked like. It has all the connection needed for your ESE power distribution or IMU. This is one of the more important bits. So it's a complete set. Now the last presenter, you guys are using the 6050, right? Yeah, we were using a much different unit. We're using the LG3 G4200. For some reason, that's what we have available, so it works out. So board preparation, you tape off the area and installation. Now, this thing is available on our website, documentation. I'll just scan through this quickly to give you guys an overview, but if you want to look in depth, you can also visit our website in Synerflight.com. Look for the Synerduino tab. So this is the Arduino Uno layout. This is the Mega layout. If you can see, the Mega supports camera gimbals and GPS, while the Uno only supports telemetry. So same board, but completely different functions. Now we recommend you actually glue the cover on your IMU. That's a pretty important thing to deal with. So that's how your connection would go. All the speed controllers. This is how the PWM receivers are installed. And we have the sketch for the setup for the PPM. Yeah. For PPM, you only need just one wire connecting to the board. That's how simple it is. What's interesting is we offer the sketch with the included description. So it's already, the description's already comment there. You can actually see what each code does. In arrangement for both multi-rotors and fixed wing. So in our case, we already set up the Quad X configuration. Here, you guys can see it. That's the Quad X. So each one has its motor ID. Each number representing the digital pin. So if you can see, and this motor number here representing the output data. Okay. So negative numbers when it's powered down, positive number it's power up. This is how it looks like on the sketch. If you notice, let's say, if you look back here, roll, pitch, and yaw. That's how the arrangement goes. So let's say you want to, you can see it. Now this one is like pitch forward, roll right, and then yaw right. So if you're going to pitch forward, you want to see what the rear motor does. The rear motor pitch powered up, the front right motor powered down, the rear left motor up, the left motor down. Now that will indicate how the power is distributed to your motor. By altering it, you can actually alter the behavior of the drone. Now, if you're doing custom mix drones, you can actually play around with this data. Let's say in this tricopter configuration, right there, see it clearly. There, you can see the numbers. They're actually set on the positive, negative. If you notice on the tricopter, it's 2/3, 4/3. Basically because of tricopter is a 120-degree arm. If you talk about a radiant, how each arms are positioned, you already identify exactly how much power to give on each arm. Now then again, you have your speed controller. So your PWM commands is idle speed. You have minimum commands, that is when your drone is on a standby mode. Idle speed is how much power you want the motor to run when you arm it. Not enough to take off, but just enough to let you know the drone is already armed. Then maximum throttle is, of course, when you're taking off, you're flying, that's how the maximum throttle you give your motor. So this was set up in the configuration sketch. Max throttle, minimum throttle. Okay, this is the one we were discussing a while ago. We call it the IMU, Internal Measurement Unit. Now, pretty much some of you are familiar already with the gyroscope. Maybe some of you have done gyroscope projects related. Now, for a drone to operate, you really need to have 4 of them. You have your accelerometer, your barometer, and your magnetometer. So the barometer controls your altitude, your magnetometer controls your heading, your gyroscope controls your horizon, like how it tilts, and accelerometers controls your vertical and horizontal axis. You need all 4 of them to make a drone fly. So this is the I2C sensor. Now, on the config parameters, we already preset the whole thing. Select the sensors. Yes, we have a 6050. If you have a 6050 sensor, you can work on that too. And as for the magnetometer, we already support MMC, QMC, and HMC. HMC is the old ones, so it's pretty rare to find right now. So currently, the magnetometers you can find is either the QMC or the MMC. This is what we were talking about. Most people only see a libraries when they looking for a particular sensor, but since we're not touching the libraries here, we actually go down to the raw addressing of the codes. Yes, each sensor has an address number. It's actually, if you look at the data specs of the sensors, they are there. Is anyone still getting me, or am I taking too long? This thing can get a little lengthy though.
Okay. It's okay, sir. It's okay.
Okay. Are we back on camera mode?
Yes, sir.
Okay. So if you can see here, here's the drone. Now, I'm also gonna open the Flyway GUI. Wait, hold on. I'm going to open it now. Okay. Hold on. I'm going to switch over again. Screen. Okay, you guys seeing this now, right? Hold on. How do I expand my screen? Okay, never mind. Okay, so this is the Flywheel UI. Wait, which one are you guys seeing right now?
The ones with the circle, sir.
Okay.
Yeah.
So this UI.
Yes, sir.
Currently, this is how it goes. There's a lot of things to go here. Actually, I prefer Zoom. That way I can actually do the switch quickly. Back on 9. Looks. Okay, so anyway, I think it's best to actually do it here. So essentially, same goes with accelerometer, barometer. Hello? Are you still getting?
Yes, sir.
Okay. Screen is open.
Sir, we are not seeing your
There's, you know, I have to really work on this one. Okay, so back again. Okay, where were we? Okay. I'll just go with the presentation instead. It's the best right now. So we have the gyroscope, same with accelerometer, barometer. Another important feature is this one. Once the sensors are in, you also have to adjust your orientation. The drone needs to know which way is north, south, east, west, as well as which direction is it facing, which side is up or down, forward or back. When you get this thing wrong, definitely your drone will flip over on the first power up. But fortunately, we also did a preset already on this one to save you guys the extra trouble. You can either find it on the accelerometer page. Now this is the Flywheel UI. Graphs. You can actually see the dimensions of it. Okay, the tech telemetry ground station. So anyway, this is how the telemetry ground station looks like. You have your barometer, artificial horizon. A lot of the essential things you need to know when you're flying a drone. So let's say, let's go back to telemetry. So in the serial, there are different baud rates now. Each module has a very different baud rate in communication. If we go back, The SIK is actually mostly running on 57600, 38400 for Zigbee, and the highest will be the Bluetooth. Now, yes, we already did, we managed to do this on Wi-Fi and other types of radio, but these are the common ones people usually use. So you can adjust it on the config edge on your baud rate. Now, there are communication on Mega, and usually serial 2 is reserved for the GPS. Serial 1 and serial 3, you can set it for 2 different radios. Serial 0 is reserved for your FTTI USB thing when you're using the USB. Yeah, that's how it looks like. The center one is reserved for the GPS, while the others are good for telemetry. So this is typically how it's wired up to your Bluetooth. Now, we also include the Bluetooth configuration. When you get the set, we already preset the Bluetooth for you, so you don't need to do this procedure. But should you ever buy a new Bluetooth or use your own Bluetooth available, you can configure it to this setting. So that's how you do it on an Arduino. Now, if you're using the Zigbee, it's a very different case. So the XB, you have set the ground station as router mode, aircraft as coordinator mode. So that's how they communicate. And of course, you also have to check the serial. The serial number actually determines the destination address and the receiving. So let's say the coordinator needs to know the router's address. The router needs to know the coordinator's address to communicate properly. And both of them will have to run on the same baud rate. So your battery. So we discussed battery care. There's a full voltage, storage voltage, and discharge voltage. Recommend you get yourself a voltage alarm. This is actually one of the more important accessories when you're dealing. Now in the config, it also shows battery scaling. Essentially, the unit has a voltage sensor which actually identifies how much power you have in your battery. And from there, you can adjust the scaling of, let's say, full voltage is 5 volts going input on the analog pin. And your drain voltage would be around 3 volts something. And you play around with that consistency by adjusting the, yes, on the Flywheel UI, you adjust it here. First, you identify whether you're 3S or 4S. Which are modules? Our modules are compatible with 3S and 4S directly. But should you wish to go higher than that, you can use an external power source to run your, your speed controller, motors, and GPS. Okay. Now GPS, we're using the U-Block 6, so it shows pretty much how to configure it. We are using a setup we want is 57600. So this is the setup you want to acquire for your GPS. The protocol, we're using NMIA. So pretty much given already. Now we also set up the GPS for you to save you guys trouble, but should you need to change the configuration, we have documentation on how to do that. Now this is something you have to be aware when flying with GPS. If you're flying near buildings, you're gonna have a poor GPS lock and your drone would wander around everywhere. So if you're flying in urban areas, best to turn off any autonomous function. Now we have a camera gimbal. This one. Okay. Yeah, this thing is pretty lengthy, but we'll just get you down to the basics. One of the important things you also considered is the PID, because you need to get data from the sensor. The drone would react to that data, and the feedback loop goes applied to the motor, and then feedback again to the drone on its reaction. So if you're looking at this PID, P stands for proportion. Hold on. Let's turn it off first. Okay, so here we go. Here's the drone. So P stands for proportion. If your drone is tilting, it applies the amount of power. It applies the same amount of power to do the correction. The problem is, after it slows down, it tends to oscillate, meaning it always overshoots its direction. So what you do is input integral. What integral does is it looks at how long the drone has been disturbed at that angle. So it attempts to slow it down, preventing it from overshooting. Now this is possible for big drones. Big drones uses PI only. Since they're so slow, their mass actually stabilize all things. Now in a small drone like this, we apply the D derivative. It predicts the future, meaning if it knows it's going to overshoot, it counteracts it on the opposite direction. So every time it's disturbed, it will always go in an upright state. Okay, let's go to the next one. Okay, we go back again. So that's PID for you. Now you guys can actually find this on our website. So let's go back to the IMU. We discussed barometer. So altitude hold involves the barometer and the accelerometer. So you have two values, the PI. Now the D represents the, okay, so you have the PID, but the I is actually referring to something different. The P actually focus on your barometer. If there's a change in altitude, the barometer numbers would change. So it tries to correct it from there. Now, and the I represents the battery. How much power you have the battery, because you have to compensate. As the battery gets used up, the motor gets weaker, so you have to compensate by applying more power. And D is the accelerometer. Okay, so we go back again. Okay, so here's the drone again. So the barometer controls your altitude. You have a P that stands for your barometer, which controls any atmospheric changes as the drone went up and down. Now, this is not very accurate, so you apply the D. The D is on the accelerometer, which detects how much up and down movement the drone feels. So that will actually hold your drone in position. Now you apply the I is because it reads from the battery. That's the reason for the battery sensor. It reads how much power you have in the battery, so it compensates the output of the motor as the battery gets drained. That way you can hold altitude. Okay, back to the window again. Am I taking a bit too long? How many more minutes do I have?
Sir, maybe we can cap it until 3:40, including the Q&A session.
Okay, sure. 3:40. So enable GPS filtering. We have the navigation setting functions revolve around the GPS filtering, which if you can see. In fact, if you notice, I pretty much show you guys the correlation between the Arduino sketch and the Flywheel GUIs because both of them actually interacts with each other. So right now we're on the GPS portion of the project. If you can see the waypoint radius, basically that's how far is each waypoint marker radius. Let's say this one was set 1 meter. So anything when the drone enters that circle, that's within the radius. The drone will switch to position hold. It marks it already has arrived. Now, how it works, it's like this. Where's that one? Here, okay. So basically your position hold and position radius goes like this. Let's say your drone is outside your circle. If your drone is outside your circle, it uses maximum power to actually fly. That it relies on navigational rate. So once the drone approaches the inner circle, which is called the waypoint radius, the drone will switch over to position rate. For this one, the drone will actually slow down because it knows it has arrived to where it's supposed to be. And once it's directly inside the radius, that's where it switched to position hold to hold its position. Okay, this is actually the tuning, what it does. Now, I'm giving you guys an overview already on this. So typically, this kind of setups is used for when you're doing navigation missions, basically. When you're bringing your drone doing missions, let's say you put a waypoint, the drone actually has an acceleration deceleration right before it hits the waypoint. If you're accelerating too fast and then it approaches the waypoint, your drone will definitely do what they call a yo-yo. It actually springs back and forth until it actually settles on top of the waypoint. This is something you want to avoid. So you have the gradual acceleration, then a gradual deceleration. So we can actually introduce this later on the sketch. We have a log browser. Okay, let's open the application so you guys can see. Okay, you guys are seeing this now?
Yes,
we're in the Arduino sketch.
Yes, po.
Okay, I'll try to fix the view, but this is how big I can actually make it. So as you can see, I did the quad configuration. My minimum throttle was placed on this idle, meaning once I arm the drone, the motors would spin at this speed. Now we have the sensors. This is the gyro, accelerometer, barometer. Now, of course, you can see, right, there are several magnetometers here. Just to let you be aware, the 5883 was the old standard years ago, back in the early 2012, something like that. This is kind of discontinued by Honeywell. So most of the sensors you've been getting right now are the QMC or the MMC. Actually, MMC was recently added by us. This is your gyro orientation, meaning once you put the board in place, you actually have to align it to the orientation of the drone. You can tell because let's say the compass orientation. You compare the compass from your telemetry of the drone against your, let's say, your cell phone's compass, if you have a compass app in your cell phone. And if it's offset, that means your orientation isn't correct. You have to adjust it. There are two ways of adjusting. You can use this one will adjust your 90-degree orientation, your X, Y, Z axis. Now you can use the one, the Flyway GUI, which, hold on, I'll turn it on again. Here, the magnetic declination east-west. Now in Philippines is 2.25, like 2 and 24 or 25 minutes. That's where you adjust it. Now, when you adjust it, don't forget to hit the calibration magnetometer. When you adjust the compass, you need to calibrate it. That means your drone will have to rotate 360 in all orientation. Okay, so it's like this. Let's say here's your drone again. When you're calibrating accelerometer, your drone needs to sit still for 10 seconds. Put it on a flat level surface, let it sit still. After that, the program will notify you it's complete by removing the blue highlight. Now, if you highlight the magnetometer calibration, you will have at least 1 minute to rotate your drone 360, rotate 360, rotate 360. This will actually tune your compass. Okay. Oh boy, I think my number of screen shares are actually off now. Can I switch to screen share again? Okay. Sorry about that, switching back and forth. No, it's not working. Anyway. It's working now. Hold on. Yeah, the screen share isn't working. So here's the drone again. Hold on, I'll just switch over. It's working now. Okay. All right. Just some minor. Okay. Let's go proceed to the Q&A since we're running out of time.
Okay, our first question, sir. Any difference of this Arduino drones to something like FPV drone, or it could be the same?
Okay. When it comes to FPV drone, let's say what kind of flight controller are you using? If you're using an iNav or a Betaflight, the Arduino drone actually is what they call the ancestor of more modern flight controllers. In fact, you did be surprised that our Arduino setup was based off the multi-Wii, which is what they call the grandfather of the modern flight controllers. If you can see that, let's say you have Betaflight, you have iNav, you have Ardu Pilot, they all came from this kind of ancestry. In fact, I have here the original Ardu Pilot. This is actually running on a 2560, so it's still an Arduino Mega in heart. So when it comes to differences, it's up to the firmware. What sort of codes do you load in there? See? So if you compare it to let's say a typical FPV drone, it's not very far. In fact, the codes change, the chipset has changed, but the fundamentals are the same. In fact, the best way to understand the drone is to really actually get into the part of it, the firmware, the codes that actually decipher what the sensors are doing, what telemetries are doing, and then configure, command the motor what to do.
Okay, sir. Our next question. Is it possible to come up with a more cheaper version of Arduino-based small drone for affordable educational purpose using nano, such as using brush-type motor, just like in cheap toy drone in the market?
Okay. Technically, yes, you can actually use a brush motor and use a nano. That will give you the same function as the Arduino Uno. Very basic. Mainly, it's all manual flying. The best you can do is let's say heading hold or heads-free mode, and that's all. Yes, you can actually use brush motor. If you're not opted to get a brushless motor, you can go for a brush motor. The reason we're marking this thing with the Mega is we want to allow you to explore more higher end functions. Let's say autonomous flight mode, which a lot of the toys don't have this autonomous flight modes or flexibility that commercial drones are using. So this gets you pretty close to what a commercial drone is doing. Like those professional drone, this will get you really close to what it is. If you're using a nano, basically you just end up with a toy. But more or less, it can be a good beginner drone to learn actually the basic of how they work.
Okay po, sir. Next question po. Is the whole available on the market, and may ano po yung costing po ng exact build?
Yes, you can actually visit our website at synerflight.com and visit the Synerduino. We have our beta release available for educators. We can send you the email on quotation on two actually packages, two types of package. One packages would involve having the motors and speed controllers. However, you need to know how to solder because this thing actually requires knowledge in soldering components. You can get what they call a shield only if you have, let's say, a flame wheel sized drone, so you can actually install it on. You can get the shield only option if you have an existing drone to actually use.
Okay, sir. Does it have safety features such as automatic landing when the battery is low?
Yes. You can actually incorporate. That's the reason why we put it on advanced mode. Now, this, unlike a toy, which you don't have safety features, it also has what they call return to home. When, let's say, you lost radio connection and your drone has a GPS, you can have the drone commanded return to home from there and then auto land. However, you have to use a Arduino Mega for it to work.
Okay po, sir. Sir, do you need license for radio comms for a drone?
We are using what they call commercial frequency. 2.4 is a commercial frequency. 433 megahertz. I mean, a lot of Arduino projects uses those 433 megahertz. And of course, the Bluetooth runs on 2.4, so we're using commercial frequency. There's no what they call license on this one. However, if you're using like radios that requires commercial licensing, now that will be a different story.
Okay, sir. So, do you have any closing message, sir, to our participants for today?
A closing message. One of it is we have a Facebook group called Arduino Drones PH, and for the introduction, it's mainly a group for drone enthusiasts, basically. If you're looking at the future in robotics, and well, the future is what you make up for, so why not invent the future?
Okay, sir. Thank you so much po. And now, we are going to show the PowerPoint of the code for Mr. Clifford. Once again, thank you so much, Sir Clifford, for joining us this event.
Thank you.
Okay, everyone. So now we are showing on our screen, the code 753AD drone. And sir, the participants are asking if they can have the copy of your PowerPoint daw po.
Yes. We have on our website, you look for drone documentation. Okay. Can I open the presentation again? Oh, no, never mind. It's on our website, the Synerduino. You visit Synerflight.com. Okay. And then you go for the Synerduino page and you search for documentation. We have all the contents pertaining to our program, including recently added is for Arduino tank and boat configuration.
Okay, sir. That's very useful. So I hope everyone na-take note niyo yung sinabi ni sir, especially those na nangihingi ng PowerPoint. But once again, sir, thank you so much po for joining us this event. Yes,
and we prepared already those who really interested. You can always follow us up later on, like on the flight page or the drone developer page. We will be happy to help.
Okay po. Thank you po. Okay, everyone. The code is 75380A drone. Okay, so with that, we are going to move to our speaker. Our next speaker finished BS Secondary Education